Okay, a little more on generating data. We just used the rand, a nice simple thing between 0 and 1, and then made it bigger or smaller. We multiplied it by 1.6 to get a random number between 1 and 6. Um, and that's okay, but you might want to generate normal random variables, and I think we did that way back in module 2, but as a refresher, the way I would generate a normal random variable with a particular mean and standard deviation. So suppose I want to produce a standard normal random variable, so the mean would be 0 and the standard deviation would be 1. I say equals, and it's the norm inverse command, norm inv. Then for the number, I use a regular random variable between 0 and 1, so ran. Then I need to tell it the mean, so in this case I want a mean of 0, and then I need to tell it the standard deviation 1. I do that and hit enter. Whoops, found an error. Did I forget something? I don't know what I did. I thought that's what I typed in. Maybe I didn't. You all can look in the video, or I can look in the video later and see what I didn't type in correctly. But so it's norm, N-O-R-M-I-N-V, open parenthesis, rand, R-A-N-D, open and close parenthesis. Maybe I forgot the close parenthesis there or something. I don't know. Comma, 0, comma 1, and then close parenthesis and hit enter. And now if I pull down a bunch of these, notice there are some negative ones, some positive ones, and I could make a histogram out of this, just to kind of show you that this is a normal variable between 0 and 1. Sorry, between 0, a normal random variable with mean 0. Let me just do 100 of these. And now I'm going to do my my bins, and I'll do those bins. I'll see what's less than -3. That's 3 standard deviations out. -2, -1, 0, 1, 2, 3. And then anything now this is going to be less than or equal to 3, and so I'll go with bigger yet, and I'm going to center these, and so this will be -3 or less, -2 to 2 -3, and so forth. So I highlight that, I do my equals, and if I want my frequencies, it is just that, frequency. And then I need my data, so that goes from 1 to 100. So I go here to 10 and then add a 0, comma, then I need my classes, and I do all but the last one. That's why I could just write bigger, all but the last one. And again, this is a vector command, so I hold Control and Shift and hit enter, and notice this looks kind of like a normal distribution. So it's a little misleading here, because actually what we're counting are the numbers between here. So these aren't centered at 0. Again, if I wanted them centered, I'd have to make the bins a little different, and we can do that. So for instance, if I want this, instead of the numbers between 0 and 1, if I want it centered at 0, I could use bins of like 0.5 here, and I'll do a minus 0.5. Now I'll get an error if I put a minus 0.5 here, and so I am going to kind of, okay, if that's minus 0.5, that's minus 1.5. And now I'll do a minus 0.5, and then 2.5, and here I think I'm still going to leave that as well, I guess I'll do 3.5, minus 3.5, and then make this 1.5 and 2.5, and so now this 41 is centered, are all the numbers between minus 0.5 and 0.5. So somewhere, you know, the things representing around 0, and you know, I can see that that's 41. You know, and this, so this is looking even more like a normal distribution now, I think, in that I've got that nice middle one that's biggest, and then the 25 and 19 and so forth. And now I can also look at going back to what I had, the minus 3, minus 2, minus 1, 0, 1, 2, and 3. Now if I want to look between plus or minus 2 standard deviations, that's this much, okay, because it's no bigger than 2 and definitely bigger than minus 2. And if I look at that, well, that's 98% of the data, because I only have 1 there and 1 there. Okay, and it's supposed to be around 95%, so that looks pretty good. If I want to look at between plus and minus 1 standard deviation, I actually have to just look at these two, and when I look at that, I see that that is 29 and 36, so that's 65%, and that's supposed to be about 68% of the data, and so you see that's very close. So, you know, this really is generating a random normal distribution. Now I probably wouldn't use it exactly this way for zeros and one, or sorry, but for a 0 and then a 1, a standard normal, but maybe I would. But I can also add that to some other data. So suppose I have some X and Y data, you know, and here I'm just going to do some X and Y data between, say, 0 and 20. So I'm just going to say rand between 0 and 20, and I'm just going to make a few of these so you can kind of see, you know, what we would do. And then suppose I want to generate data that you know, is something like y equals 3x plus 2. Okay, so this is equals 3 times, here's my x value, so I click on that, plus 2, enter, and pull those down. So that has no randomness to it, but now remember that with scatter plots and regression, we actually assume that the random error at each x value is, for the y's, is a normal distribution. And so I can add on to this my normal distribution. Now that's a, I have to do norm inverse. Okay, and then my rand, R-A-N-D, comma, and in this case, so I want 3x plus 2. Now my mean, if I'm doing this particular application, should always be 0. Okay, the mean should always be 0 if I'm doing a scatter plot like this and trying to show some sort of upward or downward trend. That should be 0 because it should be centered on our line. But then it's the standard deviation. And again, if I use a standard deviation of 1, then that's going to mean my 68%. But usually I'll think about two standard deviations. I want 95% of the data between plus or minus 2 standard deviations, or let's say I could even think about 3 standard deviations and say, well, I don't want anything 3 standard deviations to go above whatever. Well, suppose, yeah, I don't really want my numbers to ever go above 1 as far as my deviation from the 3. Okay, if I don't want them to ever be bigger than 1, what I might do here is do 1/3 or 0.33 because 3 times that is about 1, and so all my data should be within plus or minus 1 as far as the deviation from everything. That was kind of weird. Oh no, there it is. Okay, I got confused for a minute. So there, notice now instead of 62, it's 61.94, and I'll do all these, and we can take our 3x plus 2. That should be 17. It's 17.58. This should be 26. It's 25.79. See, so I've got that. And again, if I were to look at this on a scatter plot, so insert, and you should be doing plots of data of some kind, either column, bar charts, they're columns, something like that. So notice that it pretty much looks like a straight line, but not exactly like a straight line. So they've deviated a little bit. So let me make that a little bit smaller yet. I'm going to move it here just so we can see it. Now notice, well, move it up a little bit. Okay, what I want to do is just go in here and mess with that standard deviation. So suppose I put it all the way up to 1, and remember I have to fix everything. Now it's looking slightly more jumbled, but it's still not too bad. But what if I take it all the way up to 10? And do that. Now my data look much more random. However, it still looks like that if I did a linear regression, I would get p-values for the slope that shows that it's significant, I would guess, because that still looks like very much an upward trend. I'm not sure how big I would have to go here on the standard deviation. If I go clear to 100, I'm pretty sure, even though I know there's a trend, I won't be able to see it Ooh, well, I say I won't be able to see it, but I still might be able to see it. I'm not, I'm not sure how that would turn up. But notice, I just make my data noisier and noisier simply by putting this norm inverse rand and then 0 always, because the mean will be 0. But the standard deviation, I can make that bigger and bigger and bigger. So if I go to 1,000 and do this, now that definitely does not look like an upward trend. However, I know for a fact they do have an upward trend, but they are so noisy, there's so much error involved at each x value that I can't see that upward trend. So that's something one can talk about with their data, is if you have really, really noisy data, it doesn't mean there's not a trend. We just can't see it, and that's a problem with statistics. I guess, a problem in the sense that statistics can't find everything, because again, if I double click on that, 3x plus 2, I am definitely putting a trend in there. It's just that the noise around that trend is so big I can't see it. Okay, but that's how you can generate random normal variables with particular means and standard deviations. And this is how you might use it if you are working with data that you have to make up. If you go find your own data, for whatever you're doing, you won't have to do this. But if you need to make up some data for something, it's really not too bad, and we can do it with a normal variable this way. I could make columns the same way. I could do random numbers with certain means and standard deviations for different columns, but just keep changing the mean. So again, say I wanted 3 columns. Here's column A, B, and C, and in this column I want norm inverse, and again I always do rand, comma, and so suppose in this column I want the mean to be 5, and we'll give it a standard deviation of maybe 3, something like that. Okay, now I'm just going to pull this over to each of those. So that's the exact same kind of random variable, but now let's say this one I'm going to give a mean of 7, and this one I'm going to give a mean of 3. And now I could highlight all those and copy those down. Now if I'm doing something with a categorical explanatory variable, with, let's say, A, B, and C, and I've got numerical response and I need to use an analysis of variance, so I can do that. But these don't have to have the same number of things in them. I could do that, and there I've generated some data that if I put it into an analysis of variance, I should get different means for each of these columns. Now whether they're significantly different, I don't know, but I should get different means because I made them that way, and I've got that bit of randomness in there. But there I've done some random data using a normal distribution for something like an ANOVA. So over here I'm thinking of like a scatter plot, and putting my upward trend in there or downward. I could have done a -3. And over here again I am doing like a categorical variable at 3 levels, and looking at numerical responses, and I gave them each a different mean. Okay, so there's a lot working with the normal inverse, but again, it's just this, once you do it a few times, it's no big deal. It's norm inverse, rand, like that, and then my mean and my standard deviation, and it's that same command every time, and so I can generate these different types of normal variables.